Now, part C is asking us for, well, which values of x would D be the smallest? Well, the D is the D would be the y values, and so if we want to find where those y values are going to be lowest, we want to second calculate minimum. So either type the number 3 or scroll down to 3 and hit enter. And then left bound, we can see, let's move the cursor to the left of that low point there, mark it with an enter, and then move the cursor to the right of that low point, enter, move the cursor back down to the low point, and we can see we get negative 0.99, a bunch of 9s. So if we round that to the nearest 3 digits after the decimal, we'd have to increase each one of those 9s. So basically we have negative 1. So negative 1 is the x value in which the distance would be a minimum, and otherwise all other points along the curve, the distance would be a maximum. So this is part A right there. Part B, we graphed it, and then part C, the distance is a minimum when x is equal to negative 1, and then we can see there's also another point on there, and most likely, looking like it's symmetric, second calculate minimum, it's going to be a 1. So 0.1, mark the left, 3, mark the right, let's put a 2 there, and notice that, again, the minimum will occur when x is approximately 1, so rounded to the nearest 3 digits after the decimal. So when x is equal to negative 1 as well as 1, the distance from any point on the curve to the origin would be a minimum. So it makes sense. Since it's symmetrical, you get away from that spot there and you get further away there, further away there. Same with over here when x is negative 1. X is negative 1, y is negative 1, x is 1, y is 1. So when the point is right there at negative 1, the distance is a minimum. So that makes sense.